Morning viewers and subscribers. Welcome back to my YouTube channel. Mr. Green here. As promised, we'll be back with more fascinating facts to, teach you about electricity. You can learn almost everything right here. My name is Ramon Green. I am a certified electrician here in Jamaica. I have, you know, worked in the industrial field for about almost 10 years now. I've worked here in Jamaica and I've worked overseas. So I have quite a bit of understanding to what this field is about. So very quickly today we want to learn about what is electricity. We have heard the question many times and it's something we use every day. You use it on your phone, you use it on your tablet, your television, your radios. And those of you who love popcorn, we just put it into the microwave, you plug that microwave in and it just pops away. That is very exciting, but what is the science behind all of this? What is electricity? What is really happening behind the scenes that you and I don't see? Well, today we'll be investigating all of that, right? And as I said, electricity is all around us. Anything you can think of has electricity. May not be usable to power a light or to power appliances, but electricity is all around us. Even our bodies use electricity. Somebody say what? Yes, our bodies use electricity. Well, if you don't believe me, why do you need a pacemaker when you have a heart problem? A pacemaker uses battery, which is electricity. Why do you need what they call that thing in a hospital? You use the thing they used to, I think it's called a fibrillator. They put it on your chest and it gives you electric charge in your body, just jump right back into life. So yes, your body uses some amount of electricity. And somebody may ask a question, then if my body uses electricity, why do I get a electric shock? The reason being is because your body cannot handle certain amounts of electricity or certain kinds of electricity. You will learn more about that in videos to come. So today we want to ask a simple question. What is electricity? And we're going to investigate that really quick. So to understand electricity, we're going to take a little step back to science class. We're going to go back to primary school a little bit to understand a certain fundamental concept or basic concept of what is electricity. So I've drafted up everything on a little whiteboard I have here. So we're going to investigate it on the right side of the board. Okay? I'm sure we want to get the camera properly so you guys can see what is really happening. Now, I have three words on the first section of this board. Solid, liquid, and gas. Sounds familiar? Yes, it is. We learn about these three things in primary school, or some of you learned about it in the early stages of high school, right? A solid, liquid, and a gas is known as the three states of matter. Correct? Am I incorrect? I'm correct. So they are known as the three states of matter, right? So I'm just saying this to say that these three states of matter, they are responsible for everything that exists in planet Earth. Everything that is made, everything that is created by God Himself or made by man is made from either solid, a liquid, and a gas, right? Either it's made from a solid only or it's made from a combination of the three or combination of the two. But they are the basic, yes, they are the basic fundamentals of our society. So, have you seen written on the board? Listen what I've written. These three states of matter are used, I left out the R here, but they are used to create what is known as an element, right? So anything these three states of matter create, they are known as elements, right? So whether you create a metal, you have a gas like oxygen. Even oxygen we breathe is known as an element. Okay, so that is basic science class to what we are trying to move towards. Okay, so we're going to focus on the word element for a short time. Element. Okay, so an element is anything that is made from a solid, liquid, or gas, or a combination of the three or two of them, or any two of them. You understand? So it is anything that is made from these three states of matter. Now, within an element, viewers and subscribers, within an element, so within an element, viewers and subscribers, within an element, we have what is known as an atom. Okay, an atom, and I'm sure that word sounds familiar to you also. This word right here, an atom. Okay, now an atom is the smallest particle of any element, whether it's copper, whether it's aluminum, whether it's board, anything in the world. An atom is basically the basic building stones of any element. It is very small. Nobody cannot see it with the naked eye. So any element is made up of millions. Millions are numbers that are undetermined of atoms, right? So the atoms live inside the elements, and an atom has unique principle, depends on the type of element they are making. So whether it's copper or board, anything at all, it has a unique principle to the type of element, and I'm going to show you right now. I'm going to show you this right now. Okay, so I'm going to draw a little section of an atom for you to understand. Now, an atom is made up of three basic things. You have what is known as protons, right? Protons. And we have what is called a neutrons, right? Neutrons. Now, these two particles of an atom form what is called the nucleus, or the center of an atom. Okay, so the center of an atom, right, or the middle, is formed by what is known as protons and neutrons. I hope all my viewers and subscribers are following me. If you believe I'm going too fast, you can always pause the video, rewind it, and you can listen again to understand what is really going on. So the center of the atom is formed by protons and neutrons. Now, outside of the middle of the atom, the nucleus, you have a significant amount of energy that surrounds the center of the atom. Now, this energy is known as electrons. Okay, now electrons are just, small what we call electric charge that revolves around the center of an atom. You see, just like how the planet revolves around this the sun, it is the same way the electrons revolves around the nucleus of an atom. Okay, so the electrons circulate. They go in a very it's not really a perfect circle, but they go all the way around the nucleus of the atom. Okay, so every atom, as I said before, has its own unique atom. The way the electrons behave is unique. So for electricity, we're going to focus on a copper atom. Okay, and I want you to pay attention to this wire I have in my hand. Now, this wire looks familiar to everybody, because I can guarantee you every house in the world, once you are properly wired electrically, you have use of these kind of wire. Now, this is a copper wire, right? This is a copper wire. Copper is an element, and those of you who do chemistry and do the sciences, on the periodic table, copper is an element, right? Now, within this copper here, there are millions of atoms. We can see it with the naked eye. Millions of atoms of just like what I've just drawn on the board. Millions, right? And they have electrons circulating around them, right? So what happens? The electrons is what does the trick. Okay, and I'm going to show you this on the board, because I have drawn a copper atom on the board, and as I said before, each atom is unique to the different type of element that is made up of. All right, so we're going to focus on the board a little bit. I've go ahead and drawn an copper atom, not perfectly drawn to scale, but I just want to do it so you can understand what I'm trying to say. Okay, now as you can see, we have P representing the protons, and we have N representing the neutrons. Now you can see that P equal 29, N, the neutron, is equal 35. Now that means the amount of protons the copper atom has and the amount of neutrons, right? So it is said in science that the amount of protons that an element have is equal to the number of electrons. So the protons is 29, so it's gonna have about 29 electrons circulating around the center of the copper atom. Okay, I hope you guys are following me perfectly, right? As I said before, if you miss a step or you miss what I said, you can pause and rewind it and play it slowly so you get it all in. All right, okay. So the electron surrounds the atom. Okay, now the thing is, we want to focus on the outer shell of this copper atom, because these circles that it make, each revolution that the electrons make around the center of the atom, each revolution ring can only hold a certain amount of electron. So as you can see, the first shell can only hold 2 electrons. The second shell holds up to about 8 electrons. The third shell holds about 18 electrons. So already we're gone about 28 electrons once we reach to the 1, 2, 3 to the third shell, right? Now the final shell is what they call the valence shell, or the outer shell, or the outermost shell. It has only 1 electron. Now the trick about this, each metal has about roughly either 1 to 3 electrons revolving around the outside of the atom. So what really happens is that, because according to science, I'm just going to focus on metals, because we all know that metals are conductor of electricity, just like the copper wire and other metals, aluminum and silver. They are conductors of electricity, meaning if you place this copper wire on a live circuit, you can receive, we all know you can receive an electric shock, or by what we do, God forbid, electrocution. All right, so please, you don't play with wires and metals that are connected to a circuit and are exposed like this. Okay, so what happens? The electrons revolve around the nucleus of the shell. Now the outermost shell, what really happens according to science, in order for this metal to become stable, then it has to either lose this last electron here, or it gains more electrons. So what happens, the outermost shell is weak, and in order for it to become stabilized, it has to, yes, so the outermost electron of this copper atom, it is weak. So what happens, this electron always, it comes off, it just travel away to a next atom, just like this. And remember, the copper atom have millions, so the electron move from one atom to the next. Hence you have the born of the word electricity. Now
Lamar,
Jesus Christ. So the electrons travel from one atom to the next, right? So as I said, because the outer electrons, they are weak, so they always traveling to the other atoms. They easily moved around, right? So imagine if this is the next copper atom out of the millions that it has, then it is moved randomly to a next atom, and then it moves on. So if it moves from this atom to this, imagine, then this atom would have gained an electron, and this atom would have loses one. But then the electron will move again to a next atom, and they all move around randomly. Okay, so hence the name electricity is born, right? So as you can see in the definition here, I want you guys to get the idea. Electricity is the flow of electrons from one atom to the next. Now the funny part about this is that it says in a uniform direction.
Now, as I was explaining a while ago, the electrons move randomly from one atom to the next. So they may move to this atom, then they come back to this atom, then they move to the other one, and they all moves in a random movement. Now, as we speak, this copper wire, this type of principle I'm explaining, this is happening to this wire right now. The electrons are moving, but they are moving randomly. So it is of no use to us. Whenever electron is being moved randomly, then it have no use to us. You cannot get a proper flow of electricity. Hence, if I should touch this wire, even though the electrons are moving, it cannot give me electric shock. So the statement said in a uniform direction. Now we have to include something for the electrons to stop moving randomly, which is their natural way of behaving in metals, whether it's copper, aluminum, any type of metal. We have to introduce something that's going to cause them not to move so randomly, because we want to get them to proper use so they can power our lights, they can power our television and our microwaves. Everybody loves microwaves, right? So we have to include something in the mix. So I made a next statement to say the electrons are pushed by a force called voltage. This I have it in red right here. Voltage. Okay? So voltage is an electrical force, right? What it does, once it's connected to a voltage, the metal, once it's connected to a voltage, it is a force that pushes the electrons. So as I said, the electrons in metals are weak, so they can easily be pushed around, right? We all know in society, once you have weak people, they can easily be pushed around. Once you're weak, people can get to do anything they want to do. And it's the same principle with a weak atom, right? An atom with weak electrons. So we apply a voltage, and how we get the voltage is when we connect it to our, like your socket outlet at home, or a battery or whatever. So if I should connect this this copper wire to a socket outlet, I just place it in there like this. I would cut it in two, place it in there. If I should touch the live end, then because the electrons are now being pushed by a voltage, if I place my hand on it, then I can receive an electric shock, because now the electrons are moving in a uniform direction. They are moving from either positive to negative or negative to positive, right? So they are now moving in a uniform direction. Hence now it become usable. It start to make sense, and then now it can power our lights and any electrical appliances, depending on the type of voltage it's rated for or whatever. It now can power our appliances. So I'm gonna do a little replica of this on the board of this copper wire now. So imagine this is the copper wire. These are the electrons, right? When it is connected to a voltage, you connect it to your plug, right? Now the electrons are being pushed now from that voltage. It is now being pushed along, and it goes into your say for instance this is your television, right? Goes into your television, then it comes out of your television, goes back into the voltage source. This time it goes back into the negative end, I would say. So it move from positive here to the negative. So it'll be pushed now from a socket outlet, pushing the electrons in this wire, goes to your television, you watch your TV, and then it's now pushed back around now, back to the negative. So hence it is called the flow of electricity. So it flows, right? The electrons flows, right? It flows from either positive or negative, depending on the type of current flow you have. Then it flows, but in this case I would just say positive to negative, right? It can be the other way around, depending on the type of current that is applied, or the type of principle that is applied to the circuit. We get to that in the next video, all right? So it is being pushed from the positive, right, to your television, and back to the negative, and it goes around and goes around. And the only way this process stops is when you disconnect it from the voltage, right? So otherwise, when you disconnect it from the voltage, then now the force is removed. Now the electrons go back to behave as they normally do. So once you unplug it, then your TV would turn off. because it is of no use to the television now, because the electrons are just moving randomly. They are not moving in a uniform direction. And your TV is designed to use electrons when they are moving in a uniform direction. So hence we have the definition of electricity. So as I said before, it is a flow of electrons from one atom to the next in a uniform direction, right? And the electrons are pushed by a force called voltage. We will learn about voltage, and there's a next term we also have to learn about current and resistance in the next video to come. Right, so please remember to hit that subscribe button, hit the notification bell, so you can get notified when we have next videos like this coming up, right? And tell about your friends, and share the videos worldwide, so we can continue keeping these good videos coming. I do hope this video helps. If you like it, give us a thumbs up, and leave a comment to let us know what you think about this video. So I'm Ramon Green. Thanks for tuning into my YouTube channel, and I do hope to post more exciting videos like this, and there's more to come. So have a good morning. Enjoy the rest of your day.